Welcome to the Knitter campus. We are in front of the Knitter Green vehicle. This vehicle is optimally designed by our students. In the mechanical design, the material, the weight and the chassis design is mainly done by our students from the scratch. This vehicle can be charged both from the grid as well as the solar charging station. In the solar charging station, we have used solar panels, a boost converter, which is a modified interleave boost converter, which was used to increase the voltage of the solar panel and which is used for charging the battery of this vehicle. When the solar potential is not available, automatically the circuit switches to the grid supply through a relay operation. And grid supply is also used for charging this vehicle. Now let us move on to the solar charging station. This is a solar panel which we have used for the charging station. It's 300 volt solar panel. Its open circuit voltage is 45.1 volt and its short circuit current is 8.8 amps. Now let us see the charging circuit. Here you can see the relay which will just switch the circuit from solar and the grid. Now you can see that the green light is glowing, which shows that now our battery is getting charged from solar. The solar voltage required is 53 and above. So when solar is giving an output voltage more than 53, it works with solar. If the solar potential is not there, for example, we are just removing the connection. So now you can see it has automatically shifted to the grid. So now the battery of our vehicle is getting charged from the grid. So that is what we can see from this circuit. So this is the interleave boost converter. Actually, the output of the solar panel is very less. We may get a voltage of around 42 volts. But for the battery, we require a voltage of 53 because say 4 batteries are connected in series whose output voltage is 48 volt. But we have to maintain the battery voltage slightly higher. So around 53 volts is required. In that case, that 53 volts is achieved using this interleave boost converter. So here, this interleave boost converter topology, the modified interleave boost converter topology, we have already discussed in session 2 of module 10. And the gain of this interleave boost converter is 6. For a conventional converter, it is say output voltage divided by the input voltage is equal to 1 divided by 1 minus D. So here around 6 times it increases the voltage. But we will just reduce the duty cycle in such a way that we will get an output voltage of around 53 volts. Here you can see the Arduino circuit which is used for firing the thyristors of this interleave boost converter. So in case of the interleave boost converter, we have used MPPT technique. The perturb and absorb, the conventional MPPT technique is used in this case. So here the firing angle for achieving that MPPT is obtained using the Arduino controller. Coming to the grid side, usually the supply what we get is 230 volts AC supply. So which is rectified using a rectifier and we are getting here 53 volts from the grid. And after that, once the solar is not available, automatically this relay switches the solar circuit to the grid circuit. Now let us move on to the battery arrangement. The permanent magnet DC machine as well as a charge controller plays inside the vehicle. This is the battery arrangement and there are 4 batteries of 120 Ah 12 volts battery which are connected in series. So the total output voltage will be 48 volts. And here this is the controller for the motor and here this is the permanent magnet brushless DC motor. Now I introduce one of our student, Mr. Ajay Godara, and he is the director of innovative skill who has started a startup at Knitter Chandigarh. So he was the main brain behind this design. So let me first introduce him and now he will be explaining the mechanical design of this vehicle. Ajay, can you tell me what mechanical changes have you done in this vehicle to make it optimal? Just tell about the material what you have used to reduce the weight of this vehicle.
First of all, we optimize the design with the design software SolidWorks we have used, and after that we chosen best material with lightweight so that we can reduce the weight of the vehicle, and we have used aluminum alloy in maximum part of the vehicle, and we have reduced the extra excess weight like from here and the different location of the chassis as well also. So after that our vehicle is very having with less weight so that it can perform very well.
Okay, that's good. And Ajay, can you explain about the drivetrain?
Yes, ma'am. A drivetrain is optimally designed according to the motor requirement as well as our output speed requirement. Our output speed requirement as per ICAD rule and norm for vehicle approval, that is 25 to 30 kilometer. So our motor RPM is 3000 for obtaining 30 kilometer per hour speed on the tire on the road. We have to convert 3000 RPM to 300 RPM. For that we have used 10:1 gear ratio, and with the help of that we are obtaining 30 kilometer per hour speed of the vehicle. Similarly, we use two damper on the both the side for absorbing the damp for on road and off road utility.
And can you tell about the charging time? Like how much charging time does it take?
It will take approximate 10 to 12 hours. According to our calculation, it took 11 hours after for one charging for full charge.
So this is lead acid battery.
Lead acid battery.
Okay, and what is the range it is giving? How much kilometers can it travel in one charge?
Right. After optimizing electrical circuit and as well as mechanical design, this vehicle is well as per industry, as per requirement in the market. After one charge, it will go 100 kilometer. But in all available electric vehicle in the market, they used to go 70 to 80 kilometer. And also load carrying capacity of this vehicle is higher as compared to the standard electric vehicle in the market.
Okay. Thank you, Ajay, for your
you.
explanation. And with this, we come to the end of the session. And I think you will also go and design such a vehicle. For future, we are just planning to design an inverter which is bidirectional in such a way that this vehicle, the battery here, can even give power to the grid. So that is our future scope in this vehicle. Thank you.